Hi, everyone. Hello and good morning to our attendees located in America, and good evening to all attendees which may have joined from Europe. We welcome you to our today's Scene What is New session, which will introduce the latest software enhancements in Scene 6.1 and Scene 6.2 to you. With me is my colleague Kat Ashir. He's our sales engineer and expert in the US, and I'm really pleased to have him on the in the line or on the board for this meeting today. Qatar will especially concentrate on the features and the feature enhancements we did provide in the Scene version 6.1, and he will also provide a short insight into the latest Scene version 6.2, which focuses on our new on-site compensation tool, which we have launched together with the latest FocusS scanner generation. If you have questions during the call, feel free to ask this question to us. For this, you can use the Q&A panel you may find on the right-hand side of your screen. You will be muted during the call, and whenever you have a question, feel free to add it to the Q&A panel. We have a slight delay in providing the screen and audio to you, so just whenever the question comes up, direct it to you right on time, to us right on time. The session will be recorded, and we also will provide the session to you afterwards. This was it from my introduction point of view. I am really glad to hand over the microphone now to Kader, and enjoy the session, and let's speak later again. Thank you.
Thank you very much, Katrin, for the introduction. Can you hear me clearly?
Yeah, you're
okay. Good. Then I'll get started.
Yeah.
Okay, so my name is Cutter Shea, and I'm a sales engineer with FARO Technologies, and I've been working very closely with Scene and the Focus Scanner. And in our newest version of Scene 6.1, we've got some new features that we want to introduce to you. So the first one would be Scene Capture, which is a form of Scene which is used exclusively for the FARO Freestyle, the handheld scanner. Formerly, it used to live exclusively on a tablet, and you'd have to capture all your data and then open up Process on the desktop. But now, processing can be done on the tablet. There's also the cleanup feature, which is within the process, which is a nice little added bit to allow you to clean up all the stray points that come up when scanning with the Freestyle. Additionally, there is the open option, which sounds quite simplistic, but is actually fairly useful, as you're allowed to open various projects along the way and get processing done and then move along from there. Now, Scene Process is also a part of Scene, which is used exclusively for the FARO Freestyle, and the additions that have been made to Process are the same as above, but now with meshing. And the meshing that can be created from the Freestyle data can then be exported in the various mesh file types to be used for computational fluid dynamics, heat transfers, and different meshing needs for different computer programs. But jumping on to the additions from Scene, where most of the additions have been made, the first one is that we've pre-installed WebShare Cloud to go. Now, previously, you would have to go to the FARO app web store and download WebShare to go. But now that it's already pre-installed in Scene, it is also attached to the Scene license. So if you have an active license with the maintenance, then you're good to go and use WebShare to go. We have also added a target-based registration to the new interface. Previously, you were only allowed to have a top-down view or cloud-to-cloud registration, and if you wanted to do target-based, you would have to switch over to the old user interface, which was, just a hurdle that you had to work around or go over. But we've included it now in the processing, so it making things much simpler. We've also included the registration reporting and exporting as a PDF. Previously, you just would have a screen to look at, and if you wanted to save that information for later, you'd have to take some screenshots, but now you can export the entire report as a PDF and archive that for reference in the future. Meshing, as mentioned earlier, is another great feature that's been added to Scene. You can mesh entire scans, or you can mesh just a small piece of a scan through the selection tool or by creating a clipping box. New filters have been added to processing. This allows for more control over what filter is applied, and more importantly, when, because there were some established workflows that our customers had created that these filters were being thrown in automatically in Scene 6, and they were disrupting the established workflows of some of our customers. So just having these new filters and being able to choose when they are affecting the point cloud gives you much more control. So I'll jump over here to Scene Continued. Again, I've mentioned the new filters, but also the greater control over when they're enacted. Also, the measurements and clipping boxes are now linked to scans, clusters, or the entire work level. Previously, measurements and clipping boxes used to be applied to the workspace level only, and that got confusing about which clipping box was applied where, or what measurement and where did I take that measurement. But now you get more clarity, and it's, again, better way to control your point clouds and the manipulation that you're doing of them. Now, another feature that's been added to WebShare is the multi-layer overview map. If you are familiar with WebShare, the very first view that you're given when you select a project is the top-down view showing all of the scan positions. Now, let's say you had a multi-story building. What would happen in the past is it would show just the roof of the building, and you'd see all the scan positions underneath it, and there's no context as to whether what floor or what elevation those scans are on. With this new multi-layer overview map, you can create clipping boxes of each floor, and then within WebShare, you have the option to view just those layers, so it gives you more context to your top-down view, which scans are in which floor, and allows you to view, from a top-down angle much better. We've also eliminated the multiple polygon selection tools. Currently, we now have only one polygon selection tool, which eliminates some of the confusion that was caused between a loaded scan selection tool, a scan point selection tool, which used to be different. And finally, we have improved the speed of the project point cloud creation. Full color has been optimized, and in Scene 6, the full color option used to take a lot of time, and now we have improved that greatly. So that's just the roadmap for what we're going to do, and right now I'll open up Scene and go through each one of those options. So what we have in Scene 6 and beyond is this new interface that you're seeing here. It's been described as a wizard interface of sorts, where you can follow the tabs on the top from left to right, and it kind of walks you through the process of creating a scan point cloud. So you can use the tabs at the top to import the scans, process, register, explore, and then export, or you can use these tabs down lower to process, register, and then create your project point cloud. But now let's jump into all of the processing options that have been added. So from the get-go, you get the choice of every single scan. You can choose an individual scan to process. You can choose the cluster of scans. This house 1 cluster selects effectively house scans 6 through 14. Scans will do, this is a higher level cluster, which will register or process house 1 and 2, and then you can also choose to do the entire workspace. But should you choose your cluster, your scan, and your workspace, you would then click on Configure Processing in the upper right here. So this is where those options that previously were made automatic, you now have the choice of choosing to colorize your scan immediately. In scene 6, it automatically colorized the scan, and for some workflows that have been established, a grayscale or black and white is much easier for finding targets or doing some of your initial work. So now you have the choice of colorizing the scan or not. You have the option to create the scan point cloud. I have already processed this data, so I don't have the option to unselect that. But my personal preference is to create the scan point cloud immediately. That way it's faster and easier to work with within Scene. You can also choose to perform an automatic registration. And what that would do if I had this box selected, if after processing all the scans, it would immediately jump over to the registration and the automatic registration options that you have chosen. So formerly in Scene, there were just a lot of in-between steps that we've optimized. Formerly, you would load scans, save. You would apply color and then save. Top view registration, save. Cloud to cloud, save. But in this new interface and by optimizing everything, you can choose to have your process scans jump right into registration. So you're saving just that clicking time, and we're automating the process. So some of the filters that you can select now are the dark scan point filter is one. This allows you to accept or reject scan points based on their reflectance value. Underneath, you can click on settings and set the threshold. The distance filter, you can choose to accept data within a certain range. You can ignore data that is too near, or you can ignore data that is too far. Moving on to the stray point filter, this checks the 2D grid, and it looks for large enough percentages of points with distance similar to scan points itself. So essentially, this is a great filter to apply if you're in an environment with lots of piping and lots of sharp edges. For those who are familiar with point clouds, the stray points caused by pipes and edges can make for some messy data, and this stray point filter can help clean that up automatically, so you don't have to go through and manually select all the stray. Similarly, the edge artifact filter is a lot like a stray point filter, but very aggressive. So if you run the stray point filter and you're still seeing some stray, I recommend the edge artifact filter, but be careful when playing around with the settings, as the edge artifact filter will start to delete good data, which is supposed to be there. So like all powerful tools, it'll get the job done, but if you're not careful, it can take away from what you really want. And then also we have the find targets options for checkerboards, planes, and spheres. Should you want to run a targeted registration, you can tell Scene to automatically search for these targets. Excuse me. Okay, what's next here? Okay, so these are some of the filters and the processing options, but you can also see what you, if I go to my settings options here, you can choose to have these as your default settings to automatically colorize, create your scan point cloud or the automatic registration. Again, you can select all of these to have them automatically on in processing, or keep them off and choose when to apply the filter at the appropriate time. And then down at the below the target option, you have to enter certain radii for your spheres. Should I have different radii in my environment, I could add a 0.5 foot sphere, and the scene software will start to automatically look for spheres with a radius of 0.5 foot. Okay, so after processing your data, typically the very next step is the registration. So when you're in the registration tab, you have the options of your clusters and your higher clusters than the full workspace. So if you were to run your automatic registration of the entire workspace, you go to select your method, and then on the left side here, you can choose from target-based, top view, cloud to cloud, and top view and cloud to cloud, which previously was 2 different registrations, and you'd have to run your top view, you'd get your data. If it was good, then you would save and then move to cloud. We have streamlined that process, and now you can run both concurrently. So you have, again, options here to choose off your inclinometer or your compass, subsampling, but these expert settings are interesting to familiarize yourself with. You can choose the maximum number of iterations or the number of times that the algorithm goes through its cloud-to-cloud or top-down registration. Should you have a very large project, you might want to cut down on the iterations to save time. And you can also change your search distance. So should you have many scans that are very far apart, you can leave this at a very high search distance. That way, Scene can identify 2 scans that should be registered together, even if they are, say, 20 feet apart within Scene. So these expert settings, they can help control the length of time of your registration. So if you've already got a close placement of your scans, then you can cut down on your iterations and search distance to save yourself some time. So now I want to show you guys the manual registration, which is very similar to the split view registration that was available on previous versions of Scene. So what it first gives you is the 2 clusters to choose from. I'll choose the first house 1 cluster and scan number 6. And then on the right side, the scan 2 cluster. And I want to make sure I get a scan that's also looking in the same room. Actually, I'll change this to 8 and 15 here. So now I've got my 2 scans that I want to manually mark my targets for. And immediately it comes up with the 2 low definition pictures. There we go, they just snap to high def. And you can start, I can see now that I'm looking at the same area, and just like before, you can start marking your targets. If I had checkerboards placed or spheres placed around, I would use the mark sphere or mark checkerboard target from here on the left, but I don't have any targets set up, so I'll just make some out of the planes. And you can just choose the walls like you would in a split view registration. Oh, okay. Let's try something else. Okay. And all right, let's see if it likes this floor. No. There we go. So now we can see that plane 4 has been matched, plane 3 has been matched, and plane 2, I think because I clicked on the carpet here, the planes are a little different, but for the sake of the demo, you can tell that it's recognized these targets, and we can register and verify now. And this should only take just a moment, but pulls up a top-down view. I can see that these are the planes that I've selected, and I can see that the 2 clusters are where they should be. I'm satisfied with the results, so I will go to finish. And because I had chosen targets for the optimization of the registration, you want to stick with a target-based registration. Now, had I done cloud to cloud, well, choosing cloud to cloud here would ignore the work I had done in selecting the targets, so it would have, all that work would have been for naught. So run your target-based registration, and that will optimize and finish your registration. But for the sake of the demo, I won't be clicking on that just to save some time. Okay, so we showed you the automatic registration options where you can choose, top face, cloud to cloud, and do a combo. I also just showed you the split view registration, but now I want to move on to the visual registration, which is similar to the correspondence view registration of previous versions of Scene. So you can choose your target-based or cloud-to-cloud as your final optimization, but then when you go to place and register, it comes up before. This is the screen that you typically get when registration is over to visually check. But in the place and register, if say these scans were apart, you would physically grab them, move them around to their approximate locations to help Scene, and then once you place them there, you would click finish and the registration would run. But I'm not going to do that now just for the sake of time, but this is a way to help Scene by physically placing these scans in their positions so that this is where you can cut down on that search distance and save yourself some time with registration. The next little feature that I want to show is the, what do we call it? The multi-layer overview map for WebShare. And to do so, you need to create clipping boxes. So I'm going to jump to a little top-down view and create my clipping boxes. Pull out the extension here. Rotate it so it lines up. Okay, and then move to a front view. Actually, I'll take this down to the floor. So we've got a little floor plan. And to create multiple levels, I will right-click within the clipping box, and I want to create clipping boxes along an axis. Now, to go vertically and go floor to floor, you'll be along the Z-axis and the positive axis in the positive direction. You can select how many floors you want. I'll choose 3 floors. And I like to go, instead of space between box origins as the center of the clipping box to the next center of the clipping box, I like to go distance between boxes, and that just makes more sense for me. I'm sure it's different for each situation, but after choosing your spacing criteria or option, you can now choose your spacing distance, and I'll put 1 foot between each of the clipping boxes. And let's see here, 1, hit OK. And then if I zoom in here, you can see now that we've got 3 different levels or 3 floors of clipping boxes. Now, if I were to, I want to create the WebShare data Do a quick little save. So you now have the option to click on multi-layer map. And if I were to select each one of those clipping boxes that I had just created, that overview map will now be available within WebShare. So you can check the top floor and see just the scans that were available at the top floor, and check a middle floor and see the scans that were just available in that middle floor from that top view area. And this is just a new way of visualizing floors in WebShare. Okay, so I'll close this out. Actually, I want to delete my clipping boxes. And I'll show you now the new polygon tool. So formerly in the old user interface, you had different selection polygon tools for a loaded point cloud or a scan point cloud. And now we've got just the single option. Well, you have the option to make it a rectangle, circle, ellipse, or line, but just one selection tool. And this is a scan point cloud. So if I were to grab just the edge of this room here and right click within my selection, you now have the option to delete the selected points or invert them and select everything else. And then within that, you can then delete or invert or mesh, which I'll get to in just a little bit. But that's how the new scan point polygon tool works. But if I were to load, let's load number 7 here and view it in 3D. Go to the selection tool, select just this small bit of data that was outside the window. And just like old scene, if you right click inside, you have the option to delete inside or delete outside. So those options change whether the scan is loaded or not, or a scan point cloud or not. And but what this has done is simplified having 2 polygon selection tools now into one. Okay, so moving on to the project point cloud, close this out and unload scan 7. Do a quick little save, yes. The options to close surfaces and full color detail are some of the new options. I took these scans in black and white, so I don't have the option to apply full color, but I can describe it to you. I guess I'll start with the closing surfaces. Now, if you had taken a scan at a lower resolution, you're going to have a great spacing, not great, but there will be a larger spacing between your points. And when you select these closed surfaces, it uses voxels, which are volumetric pixels, and they expand to meet their neighbors. So if you have great, I keep saying great, but if you have a large point distance, then you can use this closed surfaces to make it seem like a higher density point cloud. And as for the full color detail option, again, this has to deal with the resolution at which you had scanned. If you had done a low resolution scan and applied some color, you would be seeing some gaps in the color for where there isn't data. This is that distance between points. When applying full color detail, how do I want to say this? All pixels from the photo are placed on the surface that was created. Now, this can be very memory intensive. So this is where the temporary data folder comes up. Should your computer or laptop not have sufficient memory to run this, or if you've had difficulties or had it crash in the past, you can use an external hard drive and you can place that temporary data folder as your external hard drive to just temporarily save a lot of the point cloud and color data. That way you can apply full color detail to low resolution scans. So those were the two new options in Project Point Cloud. And now I want to show you meshing. So let's see what I want to mesh inside here. Yeah. So this is a scan of my house, and I think this table would make a nice little meshing example. So I'll go to, I like to do the clipping box for selecting the pieces that I want to mesh, and just by clicking on the table there, I can isolate it, expand to get all the legs and everything. If you give me just a minute here, don't need the floor. Pull this out this way. Okay, so I've got my selection, and all I have to do is click outside of the box, click back in, right click inside it, and create mesh using active clipping boxes. So you have the option to name your mesh. That's what you can do first. I'll just keep the default name. A watertight mesh option to click or create. Now, watertight is basically used for 3D printing, and that means that there are no holes that air or water could go out of. The example that Cy Horton used is if I had scanned this statue and just the front face of this, the back of the statue would have no data there and would be a hole. So by creating this watertight mesh, it'll automatically fill in the back of that statue as best it can. So that way it would be watertight, no gaps, and you could ship it off to a 3D printer and have it created. The next option you have is the maximum number of triangles. You can go all the way up to, what's it look like here? 2.7 million, or down as low as 5,000. But this, again, you can see gives you a finer detail to the right, but on the left, it'll create much quicker. Now, should you need more number of triangles, or the number of triangles won't cover your area, you can just you can do meshing in sequence. So you can mesh one area, reach your maximum number of triangles, create the next adjacent area and with a clipping box, and then create your mesh, and you can walk down and sequentially mesh your entire area. And the detail reduction behavior, that basically is, do you optimize to the geometry only, or do you optimize for geometry and color? And this is with the application of pictures, which allows for a more beautiful looking, almost rendered mesh. But since I am in grayscale only, I will leave it geometry only. And there's a lot of holes in this scan of the table, so I'm going to take off the watertight mesh. For now, I'll show you in the next iteration how to fill in the gaps. But I'll click create here, and it should take only just a moment to create a mesh, a solid mesh of this table. Okay, so immediately it's showing me the mesh and the point cloud data together, so that looks kind of messy. I'm going to close that out and open just the mesh. And what you can see here is a solid mesh of the table and chairs. Now that watertight option, you can see that there's a hole in the chair here where there wasn't any data, and there's gaps between the box at the bottom here. Now, should I delete this? go back to go back to the clipping box. Let's create a mesh with the gap filling. And you can see the difference. If you don't have a really great set of data, the gap filling can look a bit lumpy, as you may see here, but it does show you the power that it has to fill in the gaps. Let's just see just the mesh. So it filled in that hole in the chair there, but you can also see how much lumpier, or looks like what do I want to say here, the Marshmallow Man from from Ghostbusters is what it reminds me of. But another great feature of the meshing. And again, this can then be exported. Exported in about a half dozen different meshing types for downstream software. So that is actually all of the features from scene 6.1. What's new in scene 6.2 is the angular compensation and on-site compensation. So the angular compensation is applied only when raw scans. The straight FLS files are pulled from the SD card into scene, and that is a little processing, or a filter, you could say, for the angular compensation. It takes a bit of time for each scan to load, but after it's applied the first time, it isn't applied on future scans, on future loadings of the same scan. And the major improvement for scene 6.2 is the on-site compensation. Now, it is a verification and adjustment of the scanner's compensation, so you can see how level or off of level the scan or scene is making you. It's available in Scene and Scene LT, which means that Scene LT also has the new user interface, and it is only available for our new S-series scanners. If you may have an X-series scanners, the on-site compensation is not available with our older models. Now, just like Sai, I have not received an S-series scanner myself, so I cannot walk you through the process live, but I do have a little video queued up of his, which I can show you how on-site compensation is run. So here's an old video of my colleague Sai Horton running through on-site compensation.
Heather, one question. Is it with audio?
Yes. Can you not get the audio?
No, we cannot get the audio. I actually would have loaded it beforehand.
Okay. I can talk over it if it's fine.
Perfect. Thank you.
Okay. Okay. So he's clicking on. All right, here it is. These are the targets that are needed for the compensation. You need to print out about a half dozen of those and put them up on the walls. So you have to exit your project. It's closing now. And this is the first screen that you see. Now, you've got your options for on your scanner, on this computer, and first you need to link up your scanner. Here, hold on one second. Okay. So he's just kind of going through the options now, but you link up your scanner with your IP address, and after you've connected, it makes sure that you know what scanner you've got, the serial number that's right, the type, and the firmware version. And it'll tell you if you're level or not and the last compensation that was run. So now it goes over the placement of the targets. You need to be about 5 to 10 feet away from the wall. You need them to be within 50 degrees up or down, and then try to have one of the targets directly in front of the scanner. That way it can start and stop right on one of the target sheets. So here's a little picture of running the compensation. You can see the targets on the wall and the computer down low. They need to be close for the Wi-Fi connection. But after, again, aligning that very first target with the scanner, you can hit scan and compensate. And it turns on the scanner. It starts running as usual. But it does take about 13 minutes for the compensation to run. So after that time, you then get your report telling you that no significant improvement has been achieved, or you've gotten some good improvements. It gives you your before and after angular errors, and all these values can be saved and applied. Or if you've got a very insignificant compensation, you can just choose to not apply it. So let's see what he goes on to next. So after applying your compensation, you've got a much more level and true and honest point cloud. So that's how the on-site compensation is run. It's great to have that option in the field to be able to check your, again, your angular errors. But these are the new improvements for scene 6.1 and scene 6.2. And I'd like to open up now to questions and answers, any that have been asked in the dialog box throughout the presentation.